Go, guys. All right. So on the board, somebody tell me what page this is. 142. So open your books to page 142. And up until this point, we've only been exploring data that's linear. In other words, we're comparing two things. All right. And sometimes when you compare two things and you collect the data, it doesn't make a straight line. And that's nonlinear. There's a lot of things that have what we call a linear correlation. So let's go ahead and get started on this. Give me 1 second. I want to open up my cheat sheet here. So this section is called bivariate data. And before I read the problem, I'm going to talk to you guys about what that means. Bivariate means, like a bicycle. How many wheels does a bicycle have? Two. So it's two. So we're talking about two variables, specifically x and y. So in all these examples, I don't know if you kind of put this together, but we're comparing phone calls to the total cost of the cell phone bill. We're comparing total number of miles traveled to the cost of the cab, boat rentals per day. And so we're always comparing an x value, which is the input, and then a y value, which is the output. So let me just read this. It says that bivariate data is a set of data between two paired variables. Okay, bivariate. Now, you made a joke about bicycles having two wheels, but actually that's a tricycle. So at some point in time in Algebra 2, you would deal with three variables. Now, I suppose you could say it's trivariate, but anyways, we're dealing with two variables. If the relationship between the variables is linear, the rate of change, and this is important, I really want you to underline this, the rate of change, or what we call the slope, is constant. So in a linear function, you have, write this down somewhere, y equals mx plus b, and then we would say this is a linear function. M does not change. In other words, your rise over the run remains the same throughout the whole thing. That's why it's a linear function. That's why it makes a straight line. Okay? I don't like that N. Does not change. Okay? So, and if the graph shows a nonlinear relationship, then the rate of change varies between two pairs of points. So, Andrew has two options to invest $200. Option A earns a simple interest of 5%, while option B earns an interest of 5. Well, let me slow down here. Andrew has two options. The first option is simple interest at 5%, and then option B is 5% compounded annually. Now, what that means is the way that they add the interest, it changes the value. Okay? So let's look at the data and see what the data says. So he puts in $200. After 5 years for option A, that $200 becomes $250. Okay? Because it's 5% per year. So the first year he'll get 10%. What's 10% of 200? Or not 10%. I'm sorry, I'm saying the wrong thing. 5% of 200 is, it's not 16,000. It's $10, and so every year he gets $10 interest, okay? So every 5 years, he's increasing this by 50. Do you notice that? So when we look at this, I'm adding 50, and then when I go from this one to this one, I'm adding 50. When I go from this one to this one, I'm adding 50. So that's a constant rate of change, isn't it? Adding 50. Now look at this one. To get from here to here, I have to add 55.26 to get from here to here. We're going to need our handy-dandy calculators to figure out what that means. So if I go to mode, and I say 325.78 minus 255.26. Yeah, I'm going to. We add 70.52, so $70.52. So to get from here, we go $70.52. So this changes. So my rate of change changes. So just because this is not the same every time, option B is nonlinear. And option A is linear. All right. Now, I did this problem yesterday in class, but we ran out of time. So turn on your calculators and hit Stat and then hit Edit. And what I did is in L1, I put all the X values. In L2, I put all the Y values. And in L3, I put all the L values. And yeah, that's basically it. So this right here is option A values. In other words, I'm increasing $50 from here to here. By the way, you should be plugging this in your calculator. Many of you, if you get lucky, it's already plugged in your calculator. Okay? So I'll give you guys a second. If you don't have it in your calculator, when you get it, just kind of show me your, hold your calculator up like this so you have it in there. Okay? If you don't have it in there, grab your calculator, plug it in real quick. We're going to graph this by hand. Okay, so I'm going to continue on with the lesson. We're going to come back to the calculator for those of you that are plugging stuff in. But we're going to graph it by hand in the book, okay? And then we're going to double check with the graphing calculator. That's how you check to see if you made a mistake. So going back here, the first step, so it says the table of value gives the amount of the investment for both options over 20 years. Graph the data and see the differences in the two graphs. So I know this is nonlinear, so when I graph it, what does that mean? Yeah, it's not going to be a straight line. What about this one? That one is a straight line. So we're going to go over here to the graph, and we're going to graph the points. So I think, let me remember how I did this. Second step plot. The first one is blue. So I'm going to do A first. And so let me zoom out a little bit. So that first one, I'm going to go to 0 and comma 200. So I'm just going to plot the point 0, comma 200. Then I'm going to plot the point 5, comma 250. Then I'm going to plot the point 10, comma 300. Then I'm going to plot the point 15, comma 350. And then I'm going to plot the point 20, comma 400. And remember that when we plot this, the first number represents the x-coordinate and the second number represents the y. So in other words, I'm going to start at the origin, go over 5, and go up 200. Oh, wait, no. Back up. The first one is 0, 200. So I'm going to go over 0 and go up 200. Then 5, comma 250, which should be about here. And then 10, comma 300, which should be about here. And then 15, comma 350, which should be, or as they say where I'm from, 350. And then 20, comma 400, which should go about here. And so I'm just going to draw my line through these points. And that is it for option A. So that's option A. Okay. Now let's do option B. So for option B, I'm going to take this point and this point. So it's still 0, comma 200. And then the next one's going to be 5, comma 255.26. And so on and so forth. So I'm just going to say 0, 200 right here. But this one's just going to be slightly higher than 250. The next one will be 325. So it's going to be just a little bit higher than this one. The next one is 415, so now it's up here a little bit. And the one after that is 530, which is way up here somewhere. And so when I draw my line through those points, it kind of curves up. That's option B. Okay. So now let's go back. So as you can see, and it's really hard to draw with these tablets, but that's supposed to be more of a smooth curve. Let's go to our calculator and hit second, y equals, and you'll get a menu like this. And the plots are probably already turned on. If you have plot 1 turned on and plot 2 turned on, don't do anything. Just wait a second. But if you don't, let me show you how to do that. I'm going to select plot 1. I'm going to turn it on. Then I'm going to come, whoops, I'm going to turn this on. So I got to make sure that the on is flashing. Then I'm going to come down here. I could graph the dots or I could connect the dots. The second option lets me connect the dots. For my x values, I'm going to use L1. Remember, that was that first column. And then for my y values, I'm going to use the second column, which was L2. All right? Then I'm going to come all the way up to the top. And I'm going to do the same thing for plot 2. So now that I switch to plot 2, make sure on is turned on. Make sure the second option is turned on. And then L1. Now, here's the difference. We want our y values to come from that third column, which is L3. If you look above the 3, let me zoom out a little bit. If you look above the 3, see in blue how that says L3? You simply hit second and then 3, and it will change it to L3. It won't delete it. Go back to here, hit second, and then hit the number 3, and it should say L3. Did it work? Okay. So now the next thing we want to do is we're going to go to zoom. Since we're dealing with, we're really doing kind of like a scatter plot. We want the calculator to zoom in on the data we just put in. Oh, do one last thing. Go to y equals and make sure all these are blank. Okay? So click on y equals. If there's an equation in there, you got to get rid of it. Okay? I forget that the other classes use these calculators too. Did you figure it out? All right. Well, we'll address that in a second. Okay. So go to zoom, and then option number 9 is zoom stat. So we're doing a statistics plot, so we want to click on zoom stat. When you click on zoom stat, it's going to graph it. See how this red line curves up? That's not a straight line. It curves up.
I only have one line.
You didn't turn on the second plot.
I did.
Did you choose? You didn't choose L3. You're plotting the same thing twice.
The second plot is L3. Look at it.
Did you do L1 and L3?
Yes. You did turn it on. It was clicked on.
Okay. Yep. Any other issues? Okay.
Where did it go?
Well, anyways, I'm going to take a screenshot. We'll go over this in a second here. So I'm gonna put this in here. I'll make it small so you can see a little bit better graph. But when we graph it on the calculator, you know, it doesn't look that much different than the other one. Okay. Okay, so let's zoom in and finish the problem. So step 1 is we got to graph the data from the table. We have options A and option B on the same coordinate grid. Then it says find the change between A and classify the relationship. So they start us off and they say, all right, let's find the slope. The slope is, what's 250 minus 200? 50. Over 5 minus 0, which is 5. What does that reduce down to? 10. Now here, remember, this is x sub 1, y sub 1. This is x sub 2, y sub 2. So we're going to say m is equal to y sub 2, which is 300, minus y sub 1. What's y sub 1?
5?
Y.
Wait, oh, my bad.
Do you guys know? So this is the funny part to me. When I say y sub 2, I'm saying what is the number that I've associated with y sub 2. When I say what is y sub 1, I'm saying you guys got to look with your eyes. What is y sub 1? 250. Okay? 250. All right. Now, what is x sub 2? 10. What is x sub 1? 5. This becomes 50 over 5, which is still equal to 10. And if we do the same thing here, this is x sub 1, this is y sub 1, this is x sub 2, this is y sub 2. We're going to have 350 minus 300 all over 15 minus 10, which is equal to 50 over 5, which reduces down to 10. So my slope does not change. Okay? So because it does not change, what do I put in here? The rate of change between the data values is constant. Good job. And the graph of A shows a linear relationship. Okay? All right, cool. So now we're going to do the exact same thing because we can visualize things and look at things, but it's always better to double check with the math. So now we're going to do the same thing with the values from option B. So on this first one, right from the beginning, this reduces down to 10.5. For this one, if I say m equals, okay, let me put that in black so you guys could see it a little better. So m equals, I'm going to take y sub 2, x sub 2, and this is x sub 1, y sub 1, right? So I'm going to say, oops, no, so I'm going to say 325.78 minus 255.26 all over 10 minus 5. Let's plug that in our calculator. So I'm going to say mode. Now let me show you how to do this. I already have it in here. 325.78 minus 255.26. What is that? 70.52. So over here, this is going to be 70.52 all over 5, right? So now I got to take that value and divide it by 5. Now, here's a little trick about this calculator. My last answer is 70.52. I can just say divide by 5. Now, when I hit the division symbol, see how it says ANS? That's saying I want to take my last answer and divide it by 5. So I got 14.10. Okay. So I got 14.10. On this last one, I'm going to say 3. Oops, I did it again. So you got to be careful. 415.79 minus 325.78 all over 15 minus 10. So same thing here. I'm going to say 415.79 minus 325.78. Hit enter. 90.1, and then we divide that by 5, and I get 18.02. So this one is 18.02. So here my rate of change changes. Oh, I ran out of space there. In other words, my rate of change from here to here is 10.5, and then it changes to 14.10, and then it changes to 18, and that rate of change keeps increasing. Okay? So then what does that mean? Well, that means that it is not constant. And graph, what type of linear relationship is it? Nonlinear. Not a straight line. We know that because we looked at the graph. Okay? Any questions on it? Does that make sense to you guys? Okay. All right. We're almost done, and then you guys can have homework. Yay! You're welcome. Be thankful for homework. Be thankful for education. All right.
You know what helps us learn? Being in class. Not homework. Homework is stuff.
All right. I'm recording, by the way.
Homework is our, like, homework is a demon.
All right, let's get this done. You guys, I hear your complaints, and I understand, but we still have to do our work.
But why do we have to do school at home? Like, it's called home for a reason.
Anyways, why are the graphs drawn as line or curves at not discrete points?
It's not a yes or no question. Yeah.
Oh, I'm sorry, I put the wrong. So it goes. So write this down. I know why, because I wrote yes instead of you can calculate. So what they're saying is, why is it that we're doing it as well, let me explain what discrete points means. Discrete points means that it's just a point. You know, why are we drawing a line between them? Well, because the value will change, right? So we'll write this down and then we'll explain what it means. So calculate the value of the account at any time as the money grows. Well, they're talking about the value grows, not the money. Okay? So, for example, if you let x equal 5.7 years. In other words, there's two equations that you would plug the x into and get a y value, right? So what we're saying is, and this is based on how they compound the interest, right? This is based on how they compound the interest. In other words, what they're saying is, why does our graph, and I'll show you an example of this. We have a graph. Why did we graph it like this as opposed to why did we graph it with the line instead of that? Well, because the money is going to continue to grow over time. Well, they represent the amount of money in the account. You're missing the point of the question. Anyways, I wrote it down. Understand it or not, it's your choice. Can you determine by viewing the graph if the data have a linear or nonlinear relationship? Yes.
There you go.
Linear
That's the end.
relationships graph as straight lines. And that's it. Nonlinear relationships will curve, not a straight line. Does that make sense? Lastly, it says draw a conclusion. Find differences in the account balances to the nearest dollar at 5-year intervals for option B. How does the length of time that money in the account affect the advantage of compound interest over simple interest? Well, what they're saying, if it was your money to invest, which option would you choose? Yeah. Option B pays more interest. Okay. Any questions on that? Oh, yeah. Go back here. Okay.